forgot to record this. Okay, show me how will you do it. So take this image, do a print screen or share. You take your image, capture this image, and then take it to like a software like Paint and paste it there.
Okay, I had stopped the share because I wasn't sure how to control the audio. But what I
Okay.
was trying to say was I would have put like the four holes towards the middle where it's more red because don't you want to put the holes where there's more conductivity?
So you are trying to see where, now you see the 7 layers. You are trying to see what, you want to capture as much of the information in these 4 layers, the vertical layers, because the surface we can sample anywhere, but only after the hole we have dug. So now look at, remember, I'll share my screen again. So let's see, is the system on? Okay, so if you look at this, the whole idea that we started with this diagram at the top, that this is where our pickleweed was. These are the areas. So we are trying to understand what is the soil in this area. Why are the pickleweeds growing in these areas and not everywhere else? Because these used to grow everywhere else. But once we have completely contaminated this area and made it into a dump, so now the pickleweed doesn't grow anywhere. So now we saw in the electrical images and the electromagnetic inversions that this is what it looks like. So if you sample the middle part of this diagram, so let's say pick a number here where you want to sample it. So there's 0 to 142 meters. Where would you want to concentrate? You thinking in the middle, meaning what? What number?
60.
60. Okay. So you want to sample so where would your 4? Now you don't have to stay on this blue line. You can go anywhere in this area and collect because the data that you want. So do you want to, if you understand the salt variation, why pickleweed is growing in this red area and the rest of the area is barren, where would you want to drill your 4 holes? At 60?
Yeah, I guess 60 will
So
do
are
it.
you going to go across this or are you going to concentrate on, where the pickleweeds are? So so let's say if you want to build on a land, so let's say, let me draw something, let me explain to you. So let's say this is a plot of land you have and you want to build your house on this plot of land. This is the map you see, this is your plot of land. So you know that in this plot, let's say somewhere there is, a little muddy soil, and somewhere there is, these are the muddy soils, and then there's some rocky soils the rest of the time. So where do you want to, so you don't know really what is underneath, but you can see some variations in this soil that you are going to build your house. So if you want to decide where in this place you're going to build a house, where would you what would you do to, like, say, that one, and then these areas are like this, and then if you want to understand this area to build your house and you have different soil types, would you want to sample all the areas or do you want to sample only the green or the blue? Let's say your size of your house is going to be that big. That's going to be the size of your house. So if you want to fit this area into this, would you just want to see that if it only fits in this brown area or the blue area, or do you want to do a sampling on your whole land to understand what is the character of your land so you can move your house and build it where you want to? My instinct would be to actually go ahead and sample this entire area to understand what is going on my piece of land. So I might drill a hole here, I might drill a hole there, definitely to cover all the different colors, because that will give me a definitely more idea. If I had to only drill 4 holes, maybe I will drill it in these areas. So at least I have covered all the different colors and as much of the difference in the area as possible. So I know that the foundation of the house, if it is, falling in the blue or the green or the red on this area, and let's say that was a different color, so if I build my house instead of here, if I build it there, or I might want to switch my house to here, depending on. So you don't want to concentrate all your money and drilling holes in one area. You definitely want to sample that area. One of the holes you might want there, but I think it's the best idea is to cover as much of the geographic area and as much of the variation as possible to understand what is going on in the subsurface. So if you look at the very first diagram we started with, if we drill all our holes around 60, then we will get the same amount of information, but we would not know what is going on the land which that doesn't have salt. So based on that, you want to go and sample this area. So in the top diagram, then you want to sample as much of this color variation as possible. So having said that, now can you tell me where you are going to change your answer, or are you going to still stick to the same, let's say where you said 60 meters, halfway around here, you're going to drill 4 holes?
So I guess for this layer, you would want to do 1 in the middle, 1 at the top where some yellow is, maybe 1 like where that greenish part is, because you want to get a little bit where that green is, and probably like 1 like at the very bottom where it's like the red, but then you got some yellow, and then at the tip there's green. So you want to put it like in between there.
Absolutely. You got the idea. You picked it up. Write it out. That's your question number 5. So guys, then going to question number 6, it changes the thing a little bit more. So let's go and talk about that, and then I can leave you with the rest of the question, because it kind of is, you have to understand, once you soak this in, then you can, but I'm going to give you the next guidance on the next few questions. There are how many questions? Let me see. 12 questions, right? Okay. All right, so 6 we are going to now. So what is, so when you, so truthing means this. Truthing means coring. Truthing means drilling hole. So question number 6 says the ground truthing. So now you have an actual sample in your hand. Before it was all imaging. 2 types of imaging you have done, but now you are actually have a handle on the baby. The baby is out, like you now know the baby. So now the ground truthing conducted at 6 locations indicated that the organic rich layer are quite shallow and underlain by a gravelly fill. The EM inversion shown on the story map provide evidence for this fill layer. Do you understand what they're saying? That now that you have actually done a coring in these 4 areas, you saw, said that you are going to drill holes. Now you are seeing that if you look at your, so there is a indicated that the organic rich layer, there's an organic rich layer here. The organic rich layer is here. So there are 7 layers you saw. The organic rich layer is between 0.3 and 0.5 meters. So the organic rich are 30 and 50 centimeters. So 30 and 50 centimeters, there's an organic rich layer. So now that you have actually taken a sample out, so this is 30 and 50. So let's say you have drilled a hole in the 4 areas. So you drilled a hole here, and you have drilled a hole here, you drilled a hole here. And so these are the coring, the truthing data. So in the truthing data, now you can actually visually see what lies underneath, not the imaging. And you are seeing that this is between 30 and 50 centimeters, there's an organic layer. So this is how anything, this is true for if you're building a house. So this is how you will go about sampling the area. All right. So you are seeing that there's an organic rich layer at 30 to 50 centimeter underlain by a gravelly fill. Remember, this area has been heavily altered. This was used as a dump. This has used. So underneath the 50 centimeter, there is a gravel fill. So underneath the 50 centimeter, here is a gravel fill. So you cannot, you can see that in the truthing, the holes that you drilled. Do you see this in your original map? So do you see this when you drew these holes? Do you see this in the same data? What the ground truthing did and what we had said at the very beginning, is this the same thing that we are now seeing? So now you're comparing the information we got from the electrical survey. So in that one, it said up to 50 centimeter, there was a variable layer. That's all we said. Now you are seeing that within the 50 centimeter, there's a 30 to 50 centimeter, there's an organic rich layer. And below the 50 centimeter, there is a gravel fill. So do you see this difference in this top diagram and this diagram? Do you see a correlation? We saw this 50 centimeter here also, right? This was our top layer, and we said that was the variable conductivity layer on the top. We did see that that one changed to something else, a low conductivity layer. So we did see a change in the conductivity from the top layer to the middle layer. So we're seeing that also in the truthing data. We're also seeing that in the coring data. So yes.
So are we just gonna put that we like the change in numbers?
Yes, we change in numbers in the sense this one is actual values, right? We have actual values. In the top one was the change in the color, which represents the change in the electrical conductivity. So change in the electrical conductivity is observed in the story map or in the top layer diagram there, which we also saw in the coring part. When we took the cores out, we saw that at 50 centimeter, 30 to 50 centimeter, there is a organic layer, and underneath that, it's a gravel fill. And that's probably what is showing up at this layer on the top, in the top diagram. So that was the
you said after 50 centimeters is what? It's a what kind of layer?
It's a read the question number 6. It says between 0.3 and 0.5, there is an organic rich layer and underlain by a gravel fill. So this low conductivity is probably the gravel fill. So remember, all this stuff was brought in from the construction of the World Trade Center, and this was just a dump ground. So they were just dumping things in. So that's where this is the electrical conductivity showing that there is a change as you go down, and there's a gravel fill in this marshland. So this low one is probably the gravel. So this is probably why was there a change in this layer. Is probably there is a gravel here. Some kind of a gravel fill And we see that in the truthing also. So this 50 centimeter change, we did not see the organic layer in the electrical conductivity, but now with the truthing, we see that there is a 30 to 50 centimeter, that there is an organic rich layer. Here's an organic. So more we do different surveys, more information we are getting about this area. So there's an organic rich layer here between 30 and 50, and underneath 50, there's a gravel fill. So we saw the gravel fill both in the electrical conductivity and in this coring data. Somebody read me number 7 question.
I'll read it.
Please do.
The direct current encountered a hard gravel layer at about 30 centimeters depth and could not provide any information below this depth. Does the resistivity image show evidence for another vertical contact below the gravel interference? In order to answer this, consider the resistivity variations below 30 centimeters depth. Do you see evidence for a change in resistivity at depth, which will be an indicative of another deeper layer?
All right. So the ground truthing, when they did the ground, means that they cored the holes. So how I have drawn it is not entirely true, because now they are saying that we could not penetrate the whole depth here, the 500 centimeter, that they could not drill beyond the 30 centimeter. Beyond 30 centimeter, they encountered the gravel. So they could not drill the cores below because it was too hard for the core to go down. So the cores were only concentrated in the very top 30 centimeter. So they encountered a gravel fill underneath this. So they're saying, asking you that does the resistivity image show evidence for another vertical contact? So at 30 to 50 centimeter here. So this was the resistivity measure. Image. Does it show that another vertical contact, means vertical means this way, and contact means between two layers, a line between the two layers? So is there another one? So where you seeing these contact, where the gravel fill is, we are seeing that same thing in the conductivity, the resistivity image. Yes, we do. And where did we draw the other line in the resistivity map? So we drew at about 50 centimeter, depending on where you drew it. Then we drew another line at 250. So this is the one. So the gravel, this truthing data was only concentrated in the very top part. So you can see that it only 4 areas you could gather some information. You could not penetrate beyond this 50 centimeters. So this was all filled with gravel. And so that means they could not penetrate it. But in the electrical imaging, we did see in the resistivity, we did see at 250 centimeter, there was this high conductivity layer. The truthing could not prove that to us. The truthing was only done on the top 10 centimeter or 30 centimeter of this area. So write that down. So yes, there is another layer we see at 250 centimeter, this layer. We do see another layer at 250 centimeter that the truthing could not, get down to. The truthing could not get down to that depth. The truthing was only done, the coring was only done at the very top 30 centimeter. But in the resistivity measure, we do see another layer at 250 centimeter or 2.5 meters. And why do you think that was there? What made us do that layer there? What logic we did? What did the color variation represent between the middle layer and the bottom layer? Colors represent what here in these diagrams? We put the layer in there because there was a change in color, right? So the conductivity was different. Why is the conductivity different? What controls the conductivity? It's the salinity. More saline the layers are, or more salt content the layers have, more conductive the soil becomes. All right. So that's 7. So guys, 8 also asks you to do a comparison between the inversion and the electrical imaging. So look at those 2 diagrams and come up with an answer. And I will be around, next week to answer your questions. So I want you to think about this a little bit more. And then I'm going to give you an idea how to do the rest of the 3-4 questions that are there. So in the question number 9, they're asking you that they have given you all these different values that they have gathered on the 6 sides. So now look at the on page, let me share this with you so you can see it. I'm leaving you with the last part of it, so we can discuss it next week. After all, it's your lab you have to do. So look at this. So I'm taking you to question number 9. And they have given you these values. And so there are these 6 areas. So we drilled 4 holes. So now you can see where they drill their 6 holes. So they drill 6. And these are the 6 holes gave you this 6 information on thickness of the layer, and the porosity. Porosity means the pore spaces present in the soil through which fluids can move. The particle size means how big were the sand grains or the soil grains, and the salinity they found. So based on this, so site 1 has these values for these 5 parameters, site 2 has these values. So do you see any correlation? So that's the question is, do you see, so this question is an effort to help the geophysical data set. The image under the table shows the samples were acquired. Critically analyze this data set and evaluate whether there is any visual evidence of a correlation between physical and chemical properties of the organic layer and the conductivity variation in the uppermost layer of the 3D imaging. Do a simple correlation whether you compare the high and the low conductivities with the salinity grain size. So you are going to do this comparison, and so write down this number. So if you are looking at, let's say, the one of the values, so let's say you are looking at the thickness value. So if you look at the thickness at site 1 is 0.33, site 2 is 0.33, site 3 is 0.43, 4.48, then 2.8 and 8. So are these correlations, means when you correlate things, are they similar or not? Are these values similar to one another or not? And then you compare each one of these and see if the same thing is true for each one of them. Okay, so that's how you do it. So I will show quickly how I would do it. I'm going to, as I always do, I'm going to take this screenshot and I'm going to go and print it in a paint file and show you, share this with you. So stop share this one. Share. All right, so take a look, guys. So what I did was I'm going to answer question number 9. This is what I need to do. So question number 9 says, are these values correlated? So I'm going to, if I'm looking at these values, so site 1 has a value of 0.33, right? So this value is 0.33 at site 1. So you're now comparing numbers. So 0.33 there, 0.33 here. So are these numbers similar point? And these are the other values for site 3, 4, 5, and 6. So 3 has a value of 0.43. 4 has a value of 0.48. And 5 and 6 has these two values. So if you are to make a sense of if they're correlatable, what will you say? Which values are similar and which values are not?
So for values 1, 2, and 3, and I guess 4, I guess you would say they're kind of similar because like it's increasing, but then after 4, it just like drops all the way down to
Excellent.
0.28 and 0.27.
Very good. And that's exactly what you want to write. So if you look at point 1 and 2, almost there is no difference. They're the same value. Points 5 and 6, these values are same. And then this is 3, 3, this is 2, 8. They are more similar than 3 and 4 are two different values and they are mostly on the high side. So there are 3 different values. So there is this one that is most similar to, so 1 and 2 are most similar to 5 and 6 because these values are close enough. And then 4.43 and 0.48 are very different. Now this is what I did with the thickness. Now if I do with the porosity, then I will see that the porosity values are, now these ones are the porosity values. So site number 1 has 0.48. Now don't compare the numbers are very different units and stuff, but I'm going to just look at the 0.48 is here, 0.22 and 0.23 are for those two. So make sure that you are using the same, these are different looking. So we understand that these are values that are for a different thing. So now I'm going to put this one. So 0.1, 2, 3, and then this is 4. This is 4. Now tell me whether these values, this is 4. Now tell me if these values match with this. This is 4, 5, and 6. So what you are looking at is this number 4 has a value, one has a value of 0.48, right? And then these other values are as it's given. So what will you do? What will you say about this?
It looks like the porosity is decreasing.
Porosity is here is 4.8. But do you see that now if I look at these values, that this value is very different. This top one is very different than rest of it, right? That value is 0.4.
Like the thickness is high, but the porosity is low?
No, I'm just saying now we are just looking at porosity values.
Oh,
so
okay.
I'm just looking at the porosity value of 0.48, 0.22, 0.23, and 1.5, 1.9, and 1.8. So I see that the value for 1 is different in the, when I look at porosity, the value, I saw that 1 and 2 had the same thickness, right? But when I see the porosity value, 2 and 3 seems to be more similar than 1 and 2. So 2 and 3 are more similar here. So 2 and 3 is 0.22 and 0.23. And then I see that 0.4, 5, and 6 are similar. So do you see that the porosity value and the thickness value doesn't really correlate with one another? They're different. So what I saw in the thickness, there were 3 groups. What I see in the porosity are 3 different groups, where 1 is different from 2 and 3, different from 4, 5, and 6. So I want you to do this with all these and see, after all, you can see that whether there is a correlation between these 6 sites and these 5 different parameters they have plotted. Okay. just do them individually and then do them as a group and see if you can come up with these properties, that if there is something we are finding. And 10, 11, and 12 are basically your understanding of the rest of it. And so do that and we will talk about it next week. How about that? Have I left with you enough instruction that you can give it a shot and then we can talk about it so you can finish up? Anybody? Any questions? I'm going to leave you here. So what we learned today is how in science we use different tools to understand a problem. So this is a tool that we are using different tools: geophysical, geochemical, coring, electrical resistivity, to understand the problem that this is a contaminated site which had variable times, different types of contaminants were introduced and different things were done to this marsh. And now we have an altered landscape, but we still see in this altered landscape some pickleweed, which is the indigenous plant that still grows there, but it needs salt to grow. So we are understanding to see how the salt is variable over this area, because we do see patches of pickleweed, we do not see them growing uniformly. So we are doing all different kinds of studies to see the soil underneath our feet. Why is the pickleweed growing in certain places and not? And we are also doing, surveys across to see, what we understand about it. So that's the basic tool. So as you study any science, biology, chemistry, physics, geology, there are tools we use to understand a process. So this is an environmental question that we are trying to address with chemistry, physics, and geology. Give you an appreciation of how all these are interconnected and all these things we measure in science to understand different problems. So by keeping that in mind, just answer the last 3 questions. There are no hard and fast rules here, guys. There's no question yes, question no. Based on what you understood, you have the tools, write it out, and small answers, just 1 or 2 line answers for all of them. And we will discuss them next week. Okay. All you have to do is answer question 10, 11, and 12, and then rest of it, all we have discussed them, all of them.
Okay. Thank you so much, Dr. Carr.
Welcome.
So as Dr. Carr said, go ahead and work on those last few problems, the last few questions, and you can ask questions next week. Next week's session is going to be at 11 a.m. So it was scheduled for that time because that is a time when no one has a class and everyone should be free, and it also fits in Dr. Carr's schedule.
And
so
I'm going to put my email address on the chat if you need me, my phone number and my office number. So if you guys have, my office is next to Dr. Holmes's office, and it's ACL 205. So if you need me for any of this, just let me know. Send me an email or call me or stop by.
Okay, do you guys have any more questions?
No, ma'am.
Okay, great. So thank you, Dr. Carr, and you all are free to go, and you have a good rest of your day.
Thank you. Thank you for attending the class. Did you, hey, everybody, before you go, can you write down on the chat you are here? Just say, I'm here with your name. Just put your name on it. That will be the role. Very good. All right, Gabriel, Aria, Joshua. Anybody else? All right, so we'll see you next week. Have a good week.